Okay, we are at the point where we can assemble this mold now. I've got several inserts that we are going to place into these cavities of the mold base. And I've done some fit checking, but not a lot. I do know that I need to add 2/1000 or 50 micron shim to the bottom of this block because we ran into some issues facing this and getting a good flat surface and square sides and getting this bottom dimension. So I'm going to use Kapton tape on the bottom, which is approximately 50 microns thick. And then we will start placing our inserts into the mold base. I got some alcohol here that we can clean the back because this Kapton tape is old for one thing and doesn't seem to stick as good as some of the others that I've used in the past. So let's give this a wipe down. I feel like this is a cooking show or something. All right, so we're gonna do some stripes of Kapton. So even though this plate is gonna see about 100 tons of force, the fact that we've got a large plane of relatively robust polyamide plastic here, it means that we're not gonna, there's no way that all this plastic is gonna squish out through a 50 micron gap up the sides and out. So even though it's weak material, the fact that it's distributed over a large area means that it's gonna hold up against all the pressure it's gonna see. Sometimes I'll even use regular like writing paper, which is 4/1000 thick or copier paper. And sometimes that, when you compress copier paper, it'll get maybe 20% thinner. Of course, I'm bringing in particles. And it will turn shiny after it sees like 50 tons of force on it. But it usually maintains its shape, and there's another particle there. I'm just going to cut that out. But I am worried about anything getting in here. You know, a little speck of dust, or in that case, it was a microchip of metal. Here's another one. I need a cleaner assembly area. Little bubbles aren't a big deal as long as they're not going to fold over themselves. All right, I think just 3 is enough. So this is basically our adhesive backed shim. And you can get plastic shim that's color coded, which is basically this, well, it's Mylar, where this is polyamide plastic, but they're pretty equivalent as far as strength. I'm just freeing up the holes. I don't want to cover up the mounting holes or the jack screw holes to eject this insert out. So yeah, so these holes right here, they're intended to drive a screw in and then push this insert out of the hole, because this is going to be a relatively precise fit, and with precise blocks that you slide into each other, they can jam up easily. So if I didn't have these extraction holes where I could drive a screw through the insert and then push it out by driving the screw past, and then also using them as a handle to pull the blocks out, once this block goes in, it's almost impossible to get it back out without drilling a hole through the back. You can't, there's nothing to grab onto. So you got to think ahead and add schemes to actually remove this block out of the mold. Okay, so this is the A-side, and this is our first A-side insert. So I've wiped down the inside of this cavity, and now we can drop in our insert. Okay, so here's our flow channel, which is going to line up with this flow channel. And one last check on cleanliness, making sure there's no little bits and particles that's going to cause us problems. Now we can drop this mold insert in. Yeah, you probably heard the air gush out. Now what I'm doing is I'm feeling the edges to make sure that this insert is standing proud of the main parting line of the mold base. And we need that to happen such that, you know, we don't create a gap at the parting line of our mold cavity, which will cause flash. So we want this surface, this machine surface, to be slightly above this surface. But if this surface is too much higher, then we're creating a gap in our runner system here. So we can get plastic that squirts out here in the runner, which isn't as big of a problem as having flash around our part. So if you have a choice, you always want to have a clean parting line on your part and have junky flash out here in the runner system. It's just, you know, so that you're not cleaning up the part, and who cares what the runner looks like because you're going to clip it off and regrind it. Okay, so hopefully this second insert goes just as easily as the first. And let me clean the sides. I'm feeling for particles on my hand mostly, because any kind of metal chip will cause interference and problems with insertion of these precision blocks. And you also want to start it square, and a lot of times I'll find, like, I'll get one end of the insert in, but just hovering on the surface. I think this one is a little tighter. And then at the other end, I'm going to see how it fits, and then trying to keep it as parallel as possible, and then we'll just drop it and see what happens. Oh, okay, and air gushed out and dropped into place as well. And I can feel a little step where this surface is higher. And you can probably see, you know, I did a final quick run with the shell mill across this surface. And you can kind of see what happens is I'm creating hundreds of tiny little vents, you know, every time this scallop shape from the fast cut went across here, we can vent a little bit of air out, you know, because as the plastic squirts in, it's going to fill this whole cavity, and the air that's in here, you know, the atmosphere, needs to squish out somewhere or shoot out. So we've machined vents in the corner, but we also have a continuous vent just from the rough scallop. And this rough scallop also is a little forgiving in the range of microns. You know, if the mold closes off here first, but this area isn't quite in full stress or full pressure, then these scallops will, over time, slowly flatten out a little bit and aiding in closing out this side. Okay, so there we go. I'm pretty pleased with this. So I'm going to get some M5 long screws, and we will screw these inserts into the mold block. Okay, I'm back. I got a whole collection of different M5 socket head cap screws, and this is the deepest of the inserts. This is 60 millimeters. So I believe I have a 65 millimeter screw here. Which isn't, oh, 65, I believe that is the thread length itself, and we have a counterbore, so we should have 10 millimeters of exposure of thread on the bottom with this M5 by 65 millimeter. So let's see how we go. Yep, that looks good. No surprises about screws starting. They are first-time threads, so it does feel a little tight in there. But a hex key will fix that. These screws really only need to contain or keep the insert into the mold enough to overcome the pull force of the plastic part pulling out of the cavity. This cavity is bead blasted, so I'm a little concerned about bias of the part sticking, because the other mold cores currently are not, or the B side, or the part that has the ejector pins and the side that the part is intended to stick on when the mold opens, they are not bead blasted, but I have the option to bead blast those. So we are going to load this mold and shoot some first parts and see how the parts behave. Are they filling out completely? And which side of the mold are the parts sticking on? If they're sticking on the A side, then that's a big problem, because there's no ejector pins on the A side, so you'd have to pick the parts out by hand, which is very precarious, because when you're picking away at parts right next to your soft aluminum mold inserts, with this bead blast finish, you can very easily damage the insert. So if that happens, then what we're going to have to do is bead blast the mold cores on the B side, which are not grabbing and holding onto the part. Again, that's the side where the ejector pins are. Or we need to start cutting undercuts into the B side such that the bias for the plastic part to stay on the B side is always going to be on the B side. Because this mold's probably going to mold 10,000 of these parts. So we need 0 out of 10,000 times the part sticking on the A side. So yeah, there's some probability numbers involved with mold making. All right, now this mold core is 40 millimeters deep, so let's do a 45 millimeter M5 socket head cap screw. I think that Kapton tape is just about right. It's slightly high, but I think it'll settle in once the mold closes for the first time and sees the 100 tons of force. And yeah, it's a lot of times with aluminum molds, at least in my experience, is no matter how precise you are, the molding machine will set the final mold heights for everything when it exerts the 100 tons of force on it. And then you kind of just see where you're at. And mostly it manifests itself in the shims or the ejector pin plate needing to be shimmed. So, yeah, most of the work is just about done on the A side here. So our selector gate, you know, we EDM this notch into this removable sprue is set to fill this mold first. But if we pull this guy out and I spin it 180 degrees, you can see here how I can pick which gate I'm going to use by pulling it, spinning it, and sticking it back in. Now our selector is going to fill this mold cavity. I've got this part of the runner stopping short because the actual gate into the cavity is done with the B side mold insert. Okay, so if we spin around to the back again, so these molds have a backer plate, which does a couple of things. So this is the backer plate, and I'm cleaning off the particles and stuff. So I've drilled and tapped 1/2 inch 13 threaded holes, and these holes are going to be what mounts this mold to the A side of the molding machine. There's a through hole bolt pattern on the A side platen, or the injection plastic side of the molding machine, and these will bolt on to the mold. This mold base doesn't have alignment pins or anything, so we are going to rely on the tension of these 6 1/2 13 socket cap head screws. These holes, which screw into these threads to maintain the alignment of this mold. If it becomes a problem or if I see it's drifting, then I'll load this mold base and this backer plate onto the mill, and I'm going to drill 2 precision dowel pin holes. Well, actually a hole and a slight slot, and then dowel pin these two plates together. It must not be necessary, otherwise that feature would have been added to the mold a while ago. So this plate helps create the slot here at the top, which is where if we used toe clamps, the toe clamps would rest in this slot here. The other thing is that this plate does is it contains the alignment pins for the mold. So there's 4 precision holes, and then these alignment pins here get pressed into these holes, and it's a precision fit. So these pins actually have a profile to them. So this is a close clearance fit, and then the last, 20% of the pin, the diameter actually increases so that this portion of the pin is a press fit into these precision reamed holes. And then this part of the pin, even though you can't see it, tapers down ever so slightly to become a clearance fit, so that the other half of the mold, the 4 bushings will slide on and we have really tight precision. And it actually tapers. It's not like distinct step, so the alignment gets more and more precise as the two mold halves get closer and closer together until you're basically almost at a press fit. So that's why this pin is easy to start in this side of the mold, but then about there it stops, and now you've got to hammer it in the rest of the way. So I got this rubber tipped mallet, and we're creating more and more of an interference fit. And I'll probably finish off with the brass mallet. So try not to use steel hammers on molds because you can start denting and damaging. Okay, so we will do that for all four corners. Okay, so now we can put our backer plate on. Which will lock in and contain our guide pins. I'm making sure that there's no bits of crud anywhere. Okay. And let's see, the screws here, these are 1/2 inch, 13 by 1 inch socket cap head screws. I might get my air wrench here pretty soon. All right. Now, the next part that we're going to stick in here is the alignment ring, which I unpacked one already. I need to figure out where I put it. These are the screws for it. Okay, so this is the alignment ring, and this ring is what references or locates the mold on the A side of the molding machine. So the molding machine has a precision hole in its platen, and it's intended for this ring to just key right in there, which sets the mold position. Now, this mold base is purchased in the United States from Indiana, so it's all inch based, but my molding machine is metric. So this is a 4-inch circle, which is 101.6 millimeters, but the alignment ring on the molding machine that I have is 125 millimeters. So I had to make an aluminum adapter, which adapts this inside diameter or outside diameter to which is 4 inches to the 125 millimeter inside diameter of the molding machine. But we're going to use 2 flathead screws, and these 2 screws will precision locate this ring because of the cone shape of the flathead screw. So we can stick this right there. And it's a pretty loose clearance, you know, so that you don't have to fuss. So that the screws are the things that actually set the position. I wonder if this, oh, well, that's close. I gotta find a 3/16 hex to tighten these up. But for now, this this metric one will do. All right, and that is it. So on the molding machine, I'll still be able to access our gate control or our sprue here to spin it 180 degrees by pushing it out from the front. So this is the A side of the mold. That wasn't so bad. There's also, I drilled a heater hole, and ultimately I'm gonna have to drill a couple of through holes in this mold base for cooling water to pass through the mold. For setup purposes, you know, because we're gonna see how this mold acts, we don't need cooling water because we're only gonna mold maybe 100 parts. But ultimately, we need to chill this mold. I also have bolt-on heat exchange plates, which is basically an aluminum plate with a copper tube that's pressed into it, which I use sometimes. So maybe we can get away with just having external chiller plates added to this mold. because there's really not much room to get a drilled hole. I mean, a drill bit would have to pass this alignment ring or this alignment post, and then not break into the features that create the mold insert. So it's a very tight clearance. But I would use a really deep drill and just basically drill halfway through, flip over everything, and then drill this way and try to create like a 1/4 inch or a 6 millimeter water line here and one here. Can't really go this way. Actually, I may be able to. I can add one here if I wanted, but down here, the mold cavity basically overlaps the projection of this core pin. So yeah, it's real tight. But I could potentially have a hole drilled all the way across, and then a hole drilled all the way through down this way. And then you can cap the ends of the hole, your threaded holes, such that we have a water channel that is a U shape, that starts here, comes up, meets the junction, and then the plugged hole prevents leakage out, goes across, and then down this way. So we'll see, but for now we just got to get the mold working. All right, so I think that is it for the A side. Now we will pull up the B side and assemble that one next. And here is the B side. So I already test fit this mold base, or this mold insert, into its pocket over on the mill the other day. And it's really tight, so I'm of the opinion that I'll just leave it in there. If I need to, I can jack screw it out with these screws. But I'd rather just, if it's in there, I'm just gonna let it be in there. Unless, you know, it's positive, there's a 50% chance I need to bead blast this mold core, like I mentioned, for part stiction. And this one as well. So here is our second mold core. And this one was machined with a real long spindly end mill, mostly because of this surface. So the finish isn't great, but this is going to be the surface underneath the part, the non-cosmetic side of the part. So it may not be a big issue. And the roughness sometimes is actually a benefit because the plastic part needs to hold on to this piece as the mold opens. But I may have to bead blast this as well to get the bias of stiction to be correct. So this one's in here already. Hopefully I actually threaded those holes, but these are shallow pockets, so I think they are threaded. I'm going to clean out the cavity real quick with some isopropyl and a towel, and then we will stick the other mold core in. And we'll drop this guy in. Also making sure that my extracting holes are already threaded, and they are. So if I need to jack this, because I think this part is a tighter fit. Maybe not though, I don't remember. So I'm gonna try to get everything aligned as best I can. Okay, so it looks like it's engaged. And it looks like I need to tap it down without hitting the actual features of the mold core. So you kind of walk around and basically break the little angle lock that it gets. I might have to get a piece of plastic to help with this. This is a tighter fit, by the way. Oh, here's a piece of wood. This may do the trick. Okay. I can hit the wood straight. This is better. Of course it's contaminated, getting bits of plastic everywhere. I'm gonna clean this off. Okay. So this is a little more of a precise fit. I kind of judge the clearance based on the depth. So these inserts are not as deep as the the 60 and the 40 millimeter deep inserts. So there's less of a, or this is a tighter fit. You know, the tighter you can make your fit, the more accurate your mold is. But you don't want to get in a situation where you're trying to hammer in a super precise fit on a deep part, and then have it lock up halfway down, and then you can't get it back out because of that cold welding I was telling you about. So with this, it's only, you know, like 5/8 or approximately 15 millimeters deep. So you can get this out easier instead of it being deep embedded. So I made these a little tighter. All right, so now we're bottoming out. And I can feel that we're raised up just a little bit. I had the B side raised up more than the A side. But again, as this mold sees the 100 tons of force, it's all gonna kind of find its own home anyway, beyond what I'm doing with my little wimpy hammer, because I'm not creating 100 tons with this thing. All right, so come around and let me zoom out a little bit. There we go. Okay, and I'm just kind of, it's probably seated, but I'm just double checking to get that last little bit out. Sometimes there could be a little burr somewhere that the whole part is riding up on, but I think we're good there. The edge is a little, well, it's flush there. So maybe we are rocking a little bit. Let me try the old brass hammer. All right. Yeah, it still feels flush here, but not here. And it's flush here, but a little high here. So I think maybe the insert twisted a little. So let's screw it down and see how it looks. Okay, we are back. So I found the correct screws. These are buttons that I actually had to grind some of the diameter off of the head, but that's all that I had that would fit for today. But that'll work. M5 button head screws that are slightly modified. We'll stick these guys in and screw them down. Whoops. Of course it drops into the hole there. So both our inserts are in. So the next step that we need to do is to start cutting ejector pins with the placement of the ejector plate. Here is our ejector plate with our pedestals that we cut a couple of days ago. And this ejector plate resides underneath the B-side block. And for that to happen, we are going to start to stack up the base of the B side of our mold. That needs deburred. I have a deburr tool. Okay, so let me deburr this hole real quick. Oh good, I did countersink those. As you may have saw the other day, I tried to tap these holes, but got the thread pitch wrong. So now they are through holes for a 1/4 inch socket cap head screw. I think we will hold off on screwing these pedestals in. I'll have to deburr that a little better. Because we need to grind all of the ejector pins that basically are bolted into this ejector plate, which sits on the base of the mold. And to do that, we need to add or reassemble the bottom riser blocks onto the base, and then temporarily set the mold block onto the riser with the ejector pins kind of sitting on the bottom of this ejector plate here, so we can accurately measure and then cut all of the ejector pins to the right height so that the top of the ejector pin is flush with the top of the opening for the ejector pin. So let's do that. Let me, we can go and permanently bolt the riser blocks back onto the mold base. And I believe these riser blocks don't have a asymmetry to them. So with the riser block, it's got a notch machined into the side, and this cavity here is where the toe clamps will clamp the B side of the mold to the B side of the platen in the molding machine. So it basically assembles just like that. Clean the surfaces. So let's see if you can get a perspective here. And the riser blocks have flathead screws that basically just connect the base of the mold to the riser blocks, so that this is kind of a U-shaped unit. And then there's longer screws that pass through everything and screw the B side of the mold to this riser base assembly or ejector plate assembly. Okay, now with our riser blocks installed, ideally these pedestals, which reside here, will support the middle of the mold, the B side of the mold, so it doesn't flex and collapse from the pressure of injection of the plastic. And this should be the same height, which it is. It feels good there. I need to chamfer this hole a little bit, but I'll worry about that in a second. So now what I will do is we'll set the top of the ejector plate aside. This is what clamps all the pins down, so these are through holes. And we will place the base of the ejector plate into this cavity right here, like that. You can see how it, and this plate will move up and down to eject the parts out of the B side. I feel a little bit of must be something down here interfering. Or I need to chamfer. I probably need to, well, let's see how it sounds now. I'm just checking for flatness. Oh yeah, there was some little bit of something down there. So now when I tap on it, it doesn't rock. Okay. Now I'm gonna stick the B side on to the lower half of the B side of the mold. And check for any kind of particulate as well. Like so. And that is the beginnings of the bottom half of our mold. Okay. So now what we need to do is start cutting ejector pins to the right height from this surface, plus the cord out pocket. You know, there's a bunch of little pockets that house the foot of the ejector pin, and then through all of this stack up so that the top of the pin is flush with the hole, all of the holes in the mold. Now a lot of these are the same height, so what we can do is measure one, grind it, and then cut the rest of them to the same height, assuming that everything is square on the mold. So that'll save us a little bit of time. With this mold core, there's a lot of different heights. So we can't quite do the same trick, but I think we can get a lot of them to be the same height. Let me measure the heights of these. It looks like the two landings are the same for cavity 1 and 2. I'm going to roughly measure this. Yeah, it's 5 millimeters. And 5 millimeters. Yeah, so that's nice. We can cut a lot of them simultaneously. All right, so let me get all the ejector pins and we'll start cutting and grinding and placing ejector pins.